Hi everybody, I welcome you all. This session I would like to explain about synthesis process of factorization. We know that the process factorization and how to find the roots of a equation. If we have third degree and fourth degree equation, how can we find the roots? There is a simple technique, that is a Harner's synthesis process. Let us see with the example. First of all, this is the third degree equation. If you want to find the roots of this equation, how can you find this? This is the simple process. With that process, you can find the roots easily for the higher degree equations. In this process, you have to do the sum like this. First of all, use the coefficients. Here 1x cube coefficient 1 and 2x square plus 2 minus 5x minus 5 and constant term 6. If there is no any term, that means if there is no x square term, you should put 0 instead of the term. You have to put 0 here. You have to put 0 here. So 1 plus 0, 1. How many 1 into 2? You have to check with the root. For example, take x is equal to 1. That means 1 ones are 1. 2 plus 1, 3. Here 3 into 1 again 3 minus 2. Minus 2 into 1 minus 2. 6 minus 2 is minus 8. Here you have to get 0. Here this is not 0. So that x is equal to 1 is not a root of the equation. Now let us try x is equal to minus 1. Like that you have to try again and again. Here again 1, 2, minus 5, minus 6 here. Again 0, 1. 1 ones are 1, that is a minus 1. Here it is the 1. Again 1 ones are here minus 1. It is minus 6. Minus 6 into minus 1, that is plus 6. It is 0. Now you can confirm that x is equal to minus 1. This is the root of the equation. Now in the third degree equation there are 3 roots. Now you have to find again 2 roots. So now last terms 1, 1 and here the last terms are 1, 1 minus 6, 1, 1 minus 6. So now let us try it again. X is equal to same process 1 or minus 1. Here 1 or minus 1. Let us try 2. 0, same process 1, here 1. 1 into 2, 2 or 2 plus 1, 3. 3 2s are 6, 0. That means now x plus 3. Here this is the x term and this is the constant term. So x plus 3 is the root. That is equal to 0. That means x is equal to minus 3 is the one of the root. So now the roots are x is equal to minus 3, 2 and minus 1. This is the way to find the roots. Now let us see once again the equation x cube plus 2x square minus 5x minus 6 is equal to 0. Now by the synthesis process, this is the way you have to put the coefficients of the equation. Now 1, 2, minus 5, minus 6. You have to try with x is equal to 1 or minus 1 or 2 minus 2 to find the roots. Now 0, here 1 ones are 1, 3, 3 ones are 3. This is not a root. So x is equal to 1 is not a root. Now try another root, x is equal to minus 1, 0, again 1 ones are 1 minus 1. This is the root because of this is a 0. One term is excluded. That means here x square term, it is x term and this is a constant term. Now x term, x square term, x term and constant term. After solving the equation, that means x here putting the x is equal to 2, this is the x plus 3 is equal to 0. Or if you want to use this, that means x square term plus x minus 6 is equal to 0. If you solve the equation, you get the roots x is equal to 2 and minus 3. These are the two processes. This is the Horner synthesis process. Now exercise. Find the roots of the equations. First one, x cube minus 4x square minus 7x plus 10. The roots are x is equal to minus 2, 1 and 5. Second one, x cube plus x square minus 14x minus 24 is equal to 0. And the roots are x is equal to minus 3, minus 2 and 4. Third one, x cube plus 7x square plus 2x minus 40 is equal to 0. The roots are x is equal to minus 4, minus 5 and 2.